Chris, Commander Cassidy, I'm hearing you quietly but clearly. Over. Chris, I can't tell you how excited we are. We are right now in the auditorium at Central High School where your cousins, Reed and Alan, have graduated from and moved on. There are several hundred students, staff, and visitors here today. It's such an honor that you have made this possible for us, and I can't tell you how grateful we are. It's a very special day for Central. And Chris, I have a question for you. This is a special day for you. Can you tell me what is so special about this day for you?
In Central High School, this is Houston. We are currently working on the audio problem. Hope to regain it for you shortly.
Houston, Chris, we have no video, and in the control booth here we have no sound. Just letting you know what's going on. Hope we can resolve this quickly. Thanks. We're doing a test, audio test. Houston? Houston, we have a problem.
Bill, can you hear me on this channel?
Yes, Chris, I'm hearing you well now. Very well.
Well, if it's all right, let's just continue with talking while they can try to sort things out, if that's okay.
Okay, we can continue talking. I think, let me ask the audience, can you hear Commander Cassidy down there in the audience? They're saying yes. So let's just go ahead and do the best we can with the time that we have. So Chris, did you figure out why this day is special for you?
Yeah, Bill, that's a great question. Today is a very special day because it just happens to be your sister's birthday, who is also my mom. So, Mom, happy birthday. And I'm excited to hear the students' questions. What a great day this is. We'll get through the challenging technology, no problem, but let's get on with the students.
Okay, you passed the test, a very important test. So without taking any more time, Chris, we've got some questions here for you from students, and I'm going to turn it right over to them. Thank you again so much.
My name is Alexandra Oberman, and I'm a physical science student at Central. My question is, what were you thinking the first time you went into space? Thank you.
Well, going to space is just a really cool thing. When the first time you do it, there's a lot of anticipation of what will it be like, what will it feel like, how will it do, how will I do, how will my body respond, all those questions running through your mind. But also, it's a very busy time in the cockpit, so particularly on launch. You don't want to screw anything up. It's like studying for a final exam that takes a year to study for, and it's finally the exam has come. You want to pass it well. So there's all those thoughts about doing your job correctly, but the feeling on your body is just tremendous as the G-forces pick up and then the engines cut off, and boom, you're in zero gravity floating around. It's really something special.
My name is Summer. I am a student at Central High School. I am in astronomy. My question is, does food smell and taste the same in space?
Yeah, Summer. For me, my senses have remained the same. The touch, smell, so all those things. It just seems like back on Earth. And my desire to eat in certain foods has not changed. I like the same stuff that I like on the ground, and we have plenty to choose from for food. It's really kind of cool. It's like walking into a supermarket, looking down the aisles, and you can pick anything you want. We have a pantry with lots of stuff in it. So the food people at NASA do a great job, and my senses have really remained the same from since when I left Earth.
I'm Jones. I'm an anatomy student at Central, and my question is, how does zero gravity affect your blood pressure and heart rate? Thank you.
Well, that's interesting. I think, well, it's a little bit different. The fluid in your body on Earth is all in equilibrium. When you have too much, you pee. When you need more, you drink more water or fluid. And when you get up here on Earth without gravity pulling that fluid around, it all kind of pools up, and you have too much fluid. So the first day or so, you pee a whole bunch and get it all out. And during that time, your heart, I don't know exactly, but your blood pressure is trying to get used to this new fluid equilibrium that's happening. But after that, I'd say after a couple days, everything's back to normal. My heart rate is the same. My blood pressure is the same. And in fact, we have the medical doctors periodically, seems often, I don't know how often it is, but it seems like every time we turn around, we have medical exams to make sure that we're still doing well. And so it's only in that initial couple of days that it affects you.
My name is Janie Ramirez, and I'm a biology student from Central. And my question is, how has NASA benefited the United States?
Whoa, that's a really good question to think about. At one level, NASA has benefited by giving the national pride that we all feel about what has been accomplished in space. Getting people up here in the first place, orbiting the Earth, but we all think about people walking on the moon, and that is something that is unique to NASA in the whole world, which in turn is unique to the United States. So that is one part of it. And then there's the science part of it that's happening all the time, where products have been developed that for unique uses in space that have translated to the ground, like Velcro, Tang. You guys don't know what Tang is, but I'm sort of joking. But things like this, and but more specifically, medical applications. We've learned from being in space, your bones lose their bone density, much like an elderly person has more fragile bones. And the most important thing we can do is like weightlifting type exercise to keep those bones healthy, and that has translated down to projects going on on Earth on how to keep people's bone health long into life. So there's many aspects, in my opinion, of how NASA has helped the United States. But the very one thing I think of is people walking on the moon and American flag with a NASA meatball on the side of that rocket landing there to do just that.
My name is Maggie Manso. I'm a astronomy student at Central, and my question is, how many people can live on the International Space Station? Thank you.
Well, we have a crew of 6 on board, and just last week, 3 of my crewmates left. The Soyuz that we ride up in is a really small little spacecraft, really cool little machine, but it's small in the cockpit. It only fits 3 people. So to get 6, we need 2 Soyuz crews. 3 of those guys just left last week, and in about 3 or 4 days, 3 others are going to arrive up here with myself, and Pavel and Sasha are here right now, and to keep that crew of 6. But interestingly enough, on my first mission, which was on a space shuttle back in 2009, we had a crew of 7 people on the space shuttle, and we arrived at the space station, and there were 6 people here. So at one time, we had 13 people on board the space station for a couple of weeks. Now, that's a hard thing for the environmental and control system, we call it, that processes all the oxygen and removes the carbon dioxide out of our breathing air, processes our urine to turn it into drinking water, and the condensate that comes out of the air. All that stuff the system has to keep up with the number of people. So we're at a nice state of equilibrium with 6 folks. We can certainly accommodate more. And if you get on a rocket and come on up, we have 2 empty bed spaces for just a couple more days that you're welcome to enjoy a night or 2 on board.
My name is Zane West. I'm a chemistry student at Central, and my question is, do you have a sense of up and down, and would it be possible for you to talk to us from different orientations? Thank you.
Oh, yeah. There is, at the beginning when you first arrive, when you're not fully adapted, you definitely want to orient yourself when you come into a module. We call these rooms modules. When you come into a module, you want to make it look like the training environment that we have on Earth. And your first reaction is to write yourself like that. But as you get more accustomed to being in space and more familiar with each room, it's no problem to enter it in any different attitude with the floor. You can convince your brain that different faces are the floor and different faces are the ceiling. And it's kind of fun to do that, actually, to transpose that without moving your body, but to tell yourself, okay, now I'm looking at the side wall, now I'm looking at the ceiling. And that's a really fun thing to do. And I can certainly, in matter of fact, I think you don't have video right now, but if you did, you'd see that I'm just kind of spinning around, holding the microphone, and just talking to you from all kinds of different crazy orientations.
My name is Anna. I'm a chemistry student at Central, and my question is, do you always orient yourselves to each other so that you all match, or do you sometimes talk to someone who's upside down from your perspective? Thank you.
That's a really fun thing to do. Usually we orient ourselves so we're looking at each other normally. But there are some devices that have, like for instance, our treadmill is on the wall. And when you're running on the treadmill, your essentially your face is looking at the floor. And our weightlifting machine is in the ceiling. So when you're doing squats, you're doing them upside down from the ceiling. So when you talk to somebody who's using a device like one of those items or several others around the space station, it's very easy just to stay put and that person to stay put. You have your conversation in sort of this upside down looking way. And it's kind of funny at first, but then you get used to it. And if you can't stop laughing, then you just turn around and make the guy look normal.
My name is Morgan Sterling. I'm a chemistry student at Central, and my question is, when you come back from space, do you ever forget and let go of things in front of you and they crash to the floor? Thank you.
You mean in the cockpit? I think I'm trying to envision what you're talking about. If we forget to secure anything that we have floating around and then they watch them crash down. Well, it happens every now and then, but there's a checklist that we follow right before what we call re-entry. And part of that is to really look around the cockpit and make sure everything is tied down and secure. Small things like pencils have Velcro, and the Velcro does just fine to hold it to the wall. But larger things like books and procedures and cargo really needs to be strapped down tightly to survive so it doesn't come flying around the cockpit and hurt equipment, or worse yet, hurt one of us. So we pay particular attention to that very issue. And in fact, you have a future career as a NASA engineer, because that's exactly the kind of attention to detail that folks look after.
My name is Janae Jeffries. I'm a chemistry student at Central High School, and my question is, Our safety monitoring chemistry class is, you're not as smart as you think you are, so brainstorm unpleasant surprises. What unpleasant surprises can you think of that are not already in any of your emergency procedures or manuals? Thank you.
Well, I'd like to think that we've thought through many, many layers of those problems, but you're exactly right. There's always something out there that you haven't thought of that can come around and help you out, or come around and not so much help you out. And what thing do I think about? I wonder what it would be like to have a very small piece of space debris penetrate part of the space station. We train for that a lot, and the depressurization would happen. But the sort of scientist, inquisitive person in me is curious about what kind of damage that would do really, and how big of a leak it would cause, depending on the impact and how fast all that would happen. I don't want to experience it, don't get me wrong. It's not something I ever want to envision. But as I think about possible scenarios, that's one thing that comes to my mind.
My name is Emmanuel Vargas. I am a physics student at Central, and my question is, do you have to go through antibacterial procedures to ensure that you don't bring any illnesses up to the International Space Station? And has anyone gotten sick with a cold or a flu? Thank you.
Oh, Manuel, you're exactly right. We have a period called quarantine right before we launch. We actually, in the shuttle time, it was 1 week. When we launch with the Russians in Baikonur, it's about 2 weeks long, where we effectively say goodbye to those folks that are not part of the quarantine process, and sort of isolate ourselves prior to launch. And that's for one of the main reasons, is to mitigate the risk of bringing a potential virus or something up here to the space station. Now, and then also what we do, what I did just a couple months ago on launch day, is we wash down really well, take alcohol swabs, and make sure that you're clean, and the Russian doctors test certain parts to make sure that you really are nice and clean as a whistle. And then your second part of your question is, has anybody ever gotten sick? It happens every now and then. In fact, I have a little stuffed up nose right now, but my gut tells me it's not a flu type thing. It's more of just fluid shifting around and getting in my sinuses and that type of thing. It's more of a fluid shift type head cold than anything. But we certainly do want to take measures to protect from viruses getting up here.
Hi, my name is Alex Mack, and I'm a physics student at Central. My question is, have you come up with any zero-gravity games that you can only play on the station? Thank you.
Well, Alex, right off the bat, nothing that has the name like roof ball or anything like this, but we do have sort of there's a long corridor that's in the middle part of the space station, and there are certain places to go that we try to take it all the way down that corridor without hitting anything. And it's actually a lot harder than it sounds to push off from one end of the very nose of the space station, for example, and go as far back as you can without hitting any sides or walls. It's very difficult to get the perfect push-off nice and straight. There's always some kind of small side vector that steers you into something. That's probably the number one thing that I can think of that we do, is try to get the longest straight path we can.
My name is Gabriel Reeves, and I am a chemistry student at Central High. And I was wondering, is there anything that you're not qualified to do on the International Space Station, or is everyone able to do every job? Thank you.
Well, we all train for all the various jobs that happen up here. The truth of the matter is, some of us are more of an expert in certain areas than others. Most specifically about the American side of the space station and the Russian side of the space station. I've had extensive training on all the systems on the Russian space station, but I don't feel comfortable to go down there. By down there, I mean to the Russian end, and start flipping switches on their oxygen generator or anything like this. I would most certainly get Pavel or Sasha to help me do such a thing if it was needed. And just like that, just like I described, the same holds true for them on the American side. They've had training on pretty much all of our systems, but I'm more of the expert here on this part than they are, and so I would help them if they needed to do some work here. So yes, we've all been trained, but in reality, it's more divided. It's a little bit more divided, so that we keep that expert knowledge base in a few people.
My name is Miranda Renee. I am an astronomy student at Central High School, and my question is, what is the biggest challenge you face in zero gravity?
Not losing stuff. It is really hard to, especially when you open a bag of equipment, and we have lots of equipment up here, tons of it, literally tons of equipment, and it's all organized in bags and in different lockers and compartments, and there's a system a lot like a Walmart storekeeper's little gun that shoots the barcodes so they can keep inventory inside the big store like that. We have a similar system set up, and we can find where things are supposed to be, but it's only as good as the last time we put it back. And or if we open a bag and there's all kind of little parts inside the bag and things start floating away and we don't happen to notice out of the corner of our eye that some important piece of equipment just floated away. Now the good news is the air conditioning system usually finds it, and when we do our weekly cleaning on Saturdays and Sundays, we often find our missing items on the return grill of the air conditioner. So, but it is hard to get used to not having to hold on to everything or with Velcro or to capture it with a bag before it floats away.
My name is Kimberly. I'm a chemistry student at Central, and my question is, how do you wash your clothes? Thank you.
You're not going to like this answer, Kimberly. We don't wash our clothes. We wear them until either we don't want to wear that particular piece of clothing any longer, or then we have a thing called the usage rate. We get supplied a certain number of shirts and socks and underpants, and it's a certain number of days for each of those items. And when we've gone through the number of days, then we know we can change out that thing, a shirt for instance, so that we can keep the same pace all the way to the end of the mission. But when we're done wearing it, we just throw it away. There's no washing machine up here, and it's a good thing probably that you don't smell us very often, because we don't smell as fresh as we do on Earth, I can tell you that.
Chris, it's Uncle $5 bill again, and my watch tells me that we are coming right down to the end of our session. Do you know if we have any extra time considering the delay, or are we at the end?
We have a few more minutes. I can see, I look on the computer, and it looks like a few more minutes until we're going to lose the signal here. But so let's please continue with the students if you'd like, and I'm happy to do that until we conk out.
Okay, sounds good. Alan says hello. Here's our next question.
My name is Marco. I'm a biology student at Central, and my question is, can you see Earth spin from your perspective, or does it seem to stay still? Thank you.
Well, it's all in your perspective, and but really, we are moving very fast. We are moving 17,500 miles an hour, 5 miles a second. So basically, you could be sitting at your house eating breakfast and go, oh, it's time for school to start, and 1 second later be sitting from your house at your classroom table. That's how fast we're moving. And consequently, when we look out the window, the motion that we see is mostly our motion around the Earth, us moving. However, the Earth is spinning really fast underneath us, and the reason we really know that, I mean, obviously we know it from our all of our science, but on board, what we see is that we have a computer program that plots the trajectory of a space station. If the Earth wasn't moving, we would come right back over that same exact point the next time around the Earth. However, the Earth spins underneath us a little bit, so instead of coming over Oregon, if I came over Oregon right now, an hour and a half later when I come back over Oregon, I wouldn't. I would be passing a little bit out into the ocean, and then further on down and maybe intersecting with Mexico as we headed south. So Earth is spinning underneath us, and we're going really fast, but the motion that we really perceive with our eyes is our own motion about the Earth.
Hi, my name is Raven Potter Clark, and I'm an AP Biology student at Central. And my question is, are we going to have more than one space station in the future? Thank you.
Well, in the big future, that is a hope that I certainly have, that we have several places to come venture into space. But in the most practical near term, certainly while I'm a member of NASA, and maybe even while you guys are members of NASA, we will only have one space station. It's an expensive program to run. It's a great program, but it takes a lot of resources all around the world to construct the parts, train the people, to run the mission control center, to make international decisions for all the partners, and it's a big undertaking, and it's just not practical at this stage in our civilization to have two space stations up here. At some point, I really believe we will, but right now, that's not something we're trying to do.
Hello, my name is Joseph Martin. I'm a physics student at Central, and my question is, what is your least favorite thing on the station to clean, and do you have any troubles? Thank you.
My least favorite thing to clean is probably the fan, the inlet fan in our sleeping quarters. They get really nasty, and it's not because of anything about us. It's just that the clothes, all of our clothes and the lint and skin and hair that flecks off that, would be in your sheets that you could wash your sheets every couple weeks or every week, whatever you do at home. All of that ends up in the intake fan of our sleeping quarters. So that's something that's not particularly fun to clean, but it's certainly a needed activity to do often.
My name is Maddie Yang. I am a chemistry student at Central, and my question is, what is the most dangerous situation you are trained for? Thank you.
Well, the most dangerous situation probably is, well, there's three that are big. We could have a fire, could have a depressurization that I kind of alluded to in an earlier question, or we could have a thing called an ammonia leak. We have ammonia outside of the space station as part of our radiators that help reject all of the heat that happens inside. When you turn on a computer, if you put your laptop on your lap feels the heat of that battery in the computer, and we have lots of computers. Plus we have our own bodies in here, and all this equipment is making heat. If we didn't do anything, all that heat would build up and it would be really hot. So we reject that heat to space through this cooling system with ammonia in it, and if the ammonia leaked into the cabin, it's a really highly concentrated lethal gas that would be bad for us to breathe. So that's a really, really bad scenario, because if it leaks, instantly we have to put masks on, or we are at risk of not surviving the leak. So I think that's probably the scariest situation that I can envision.
Hello, my name is Madison McCammon. I'm a chemistry student at Central, and my question is, how would you extinguish a fire if one was started? Thank you.
Well, great question. The first thing that we do is we suspect that it's a problem because of electrical power. So we start turning off the electrical power in the area where there's a fire. And if that doesn't work, if the fire continues, then we'll put on masks and go to that location and use a fire extinguisher to put the fire out. And we have racks, they're kind of like a refrigerator, all with separated off into compartments. So the theory is that if a fire was inside of a rack, it would stay contained in that rack, and we could put out the fire just in that rack, and it wouldn't spread. There are some, we try to make everything as a non-flammable thing that comes on board the space station, but there is a chance that it could be an open cabin fire, in which case we would just use the fire extinguisher right on that flame and put it out. We're really close to losing this signal, and I wanted just to take the opportunity to thank you guys for coming to this event. I'm really sorry that we don't have video. You should just see all the amazing tricks I'm doing for you that you're missing out on. It's just a circus up here, and you're missing it. It's a shame. But I'm really happy that we worked through just this with the questions, and it's truly my privilege to be talking to a school that my cousins attended, and my famous Uncle $5 Bill is there moderating it. So, Bill, thanks so much for organizing it. What a treat this is for me on my mom's birthday.
Hi, I'm Marissa, and we just wanted to thank you, Commander Cassidy, for taking your time to do this. Have a good day.
Thank you, Chris. Thank you, thank you.
Okay, you guys have a fantastic long weekend, and have a hamburger and a cold soda for me, please.
Will do. Sleep well. It's your bedtime, I think.
You bet. Take care. Bye-bye, everybody.